When we look up at the moon, we're not just seeing a distant world, we're gazing at a symbol of human ambition, curiosity, and the drive to explore the unknown. For generations, the moon has inspired us to dream bigger, to reach further, and to imagine what's possible beyond our own planet. Today, that ambition is alive and well. The idea of returning to the moon isn't just about repeating history, it's about pushing the boundaries of science, technology, and human endurance. For years, the story seemed simple. America was determined to go back, and SpaceX was building the next-generation spacecraft to get us there. The partnership between NASA and SpaceX captured the world's imagination, promising a new era of lunar exploration. But, as deadlines slip and launch dates move, some have started to point fingers, blaming SpaceX's ambitious Starship for NASA's delays in returning to the moon. Headlines question whether the private sector is up to the challenge, but the truth is far more complex. Artemis isn't just a single rocket or a single company, it's a vast web of companies, technologies, and government agencies. Orion, SLS, and Starship all have to work together seamlessly for the mission to succeed. Starship is just one piece of this intricate puzzle. It's not the only cause of delay, and it's certainly not the only challenge NASA faces. SpaceX is building a fully reusable spacecraft, something that's never been done at this scale. It's not just a simple lunar lander, but a leap forward in space technology. That means tackling engineering problems no one has ever solved before, from heat shields to refueling in orbit. Testing, failing, and learning are all part of the process. Each setback is a lesson, and every test brings us closer to making moon missions routine, affordable, and safe for future astronauts. The original timelines were always optimistic, driven more by political promises and public excitement than by the realities of engineering and funding. Delays come from many sources: political pressure, budget constraints, technical hurdles, and the sheer difficulty of deep space exploration. It's not just about SpaceX, it's about the challenge of reaching for the stars. This isn't a story of failure, it's a story of immense ambition, of humanity daring to dream, and of the long, difficult road to making those dreams a reality. In 2019, the Trump administration set a bold and ambitious goal for NASA: to return Americans to the moon by 2024, just 5 years away. This announcement electrified the space community and made headlines around the world, signaling a new era of lunar exploration. The idea of boots on the moon again captured the public imagination, evoking memories of Apollo and the spirit of discovery. But behind the scenes, the reality was far more complicated. For NASA's engineers, this deadline was driven more by political motivations than by technical readiness. The timeline was aggressive, and many within NASA knew it would be a monumental challenge. The pressure created a tug-of-war. Politicians demanded speed to achieve a national milestone, while engineers insisted on the time needed to ensure safety and reliability. The tension was palpable in every meeting and design review, even as administrations changed and new leaders took office. The pressure for quick, visible results never really faded. Each president wanted to leave a mark on America's space legacy. Today, Artemis 3 is officially targeted for 2027, but many insiders quietly expect the first crewed landing to slip to 2028 or even later, as technical and logistical hurdles mount. SpaceX, a key partner, has its own internal schedules. Leaked documents suggest September 2028 is the earliest possible date, but most experts believe 2029 is more realistic, given the complexity of developing new lunar landers and support systems. The gap between public promises and engineering reality is wide, and it's a challenge NASA has faced for decades. Unlike the Apollo era, when NASA enjoyed massive funding and national focus, Artemis must achieve its goals with a fraction of the resources. In the 1960s, NASA received nearly 5% of the federal budget, fueling rapid progress. Today, the agency operates on just 0.3%, stretching every dollar to its limit. NASA must now attempt something as technically demanding as Apollo, but with far fewer people, less money, and more complex technology. Deadlines may be set by politics, but real progress is determined by the laws of physics and the painstaking work of engineering. Every step forward is hard-won. The moon won't be rushed, and neither will the people determined to reach it safely and for good. SpaceX's Starship is both Artemis's greatest strength and its biggest challenge. It represents a bold leap forward in space technology, promising to transform how we reach the moon, and eventually, other worlds. But with that ambition comes immense complexity and risk. Starship isn't just a lander. It's a fully reusable space vehicle designed to make moon trips routine, not rare. Its massive size and versatility could one day make lunar missions as common as satellite launches are today. NASA chose Starship for its long-term potential, not just a single landing. The agency is betting on a future where humans can travel to the moon, Mars, and beyond, using a spacecraft that can be refueled and reused over and over. But building something this new means inventing technology as you go. Every system, from engines to life support, must be created, tested, and perfected, often for the first time in history. The biggest hurdle? Orbital refueling. This is the key to unlocking Starship's full potential, but it's also the most unproven part of the plan. Starship needs to be topped off in space, a feat never done at this scale. Dozens of tons of fuel must be transferred between vehicles, hundreds of kilometers above Earth. It's like refueling a jetliner mid-air, but in zero gravity, with no room for error. The physics are unforgiving, and the technology must work perfectly. Despite the challenge, SpaceX has made real progress, pushing boundaries with every test, learning from failures, and moving closer to their goal. In 2025 alone, they're planning 5 test flights, with successful ocean landings and major subsystem tests already under their belt. Each flight brings new data and new confidence. Next comes a demonstration of orbital refueling, a critical milestone that will prove whether this ambitious plan can work in practice. Then, an uncrewed lunar landing will test every system in real conditions, paving the way for astronauts to follow. Each step is risky and unprecedented. There are no guarantees, only careful planning and relentless testing. Starship is a high-risk, high-reward bet. The stakes are enormous, but so is the potential payoff. If it works, it will change spaceflight forever, making the moon, and maybe even Mars, accessible to humanity in ways we've only dreamed of. But it can't be rushed. Every milestone is a mission in itself, demanding patience, precision, and perseverance. The path is slow, but the payoff could be historic. The journey to the moon is as much about innovation as it is about exploration. That's the price of revolution, and the promise of a new era in space. With Starship's timeline uncertain, NASA reopened the Human Landing System contract in late 2025. SpaceX was the sole winner, but now Blue Origin and others are back in the race. The goal: get Americans on the moon before January 2029. Blue Origin, already working on its Blue Moon lander, now has a shot at Artemis III. NASA hopes competition will speed things up, but this is as much about politics as technology. Can anyone really build a new lander faster than SpaceX can finish Starship? Most experts doubt it. Developing a human-rated spacecraft takes years. A delay for SpaceX likely means a delay for Artemis. For now, Starship remains the only real ticket back to the moon. While America debates deadlines, China quietly advances toward the moon. Their goal: land taikonauts by 2030, a deadline the world takes seriously. China's plan is methodical: build the International Lunar Research Station at the moon's south pole by 2035. They're recruiting partners, with Russia as a key collaborator. China is developing tech to use lunar resources, making water, oxygen, and fuel from the moon itself. They're 3D printing buildings from lunar soil, and planning a nuclear reactor for power. These are real engineering projects, not just ideas. China's steady progress contrasts with America's public drama. They're not racing to plant a flag, they're building to stay. The new moon race is about who can create a lasting presence. America and China have two very different moon strategies. The US is sprinting, driven by political urgency and a desire for a quick win. That's why NASA bet on Starship's revolutionary tech despite the risks. The result: public drama, shifting deadlines, and a focus on the next big milestone. China, meanwhile, is running a marathon, methodically building a permanent lunar presence. Their goals are incremental, realistic, and consistently met. America's approach is open and dynamic. China's is steady and strategic. The US is betting on a breakthrough. China is building for the long haul. Both paths lead to the moon, but the outcomes may be very different. It's not just a race, it's a clash of philosophies. The new moon race isn't just about who gets there first or planting a flag. It's a contest of ideas, ambition, and national willpower, pushing boundaries further than ever before. SpaceX's Starship represents bold innovation and a daring vision for the future. China's approach is methodical, enduring, and built for the long haul. This is more than a competition of rockets, it's a test of strategy, vision, and perseverance. For the US, it's about reclaiming leadership and proving public-private partnerships can truly work. For China, it's about building a permanent foothold on the moon and expanding global influence. The journey reveals our drive to innovate and exposes our political struggles and ambitions. Whether the next footprints are American or Chinese, it marks a new chapter for all of humanity. The real victory is in reaching for the stars, together or apart, and inspiring generations to come.